Good afternoon, class. By now you've read Chapter 6, Lesson 2, pages 204 to 209. If you'd grab your book, let's highlight a couple things or underline some things that are important. On this first page, the relative age of rocks is its age compared to other ages of other rocks. So that's a key point to underline on this page. Okay, on this page 205, key components to know are the absolute age of a rock is the number of years that have passed since the rock formed, and the law of superposition. According to the law of superposition, in an undisturbed horizontal rock, sedimentary rock layers, the oldest layer down here is found at the bottom, and each higher layer is younger than the layers above. So see how they go and they are different here? If you look there. And so let's do figure 1. Figure 1, rock layers in the Grand Canyon. More than a dozen rock layers make up the walls of the Grand Canyon. You can see the layers here. So interpret. In the white area, draw an arrow pointing from the youngest to the oldest rocks. So you would take your pencil and you would arrow up this way. So I'm not sure if I can make a little arrow. Let's see, arrow up that way, and then so that's how that figure would look. You can do that in your book. Now take a look at page 206. So things that are important are the lava that hardens on the surface and forms igneous rock is called an extrusion. And then on this one, the intrusion, magma may push into bodies of rock below the surface. The magma cools and hardens into a mass of igneous rock called an intrusion. And you can see that right here. That's an intrusion when it's in. And then there's the fault, which is a little below. The fault is a break in the Earth's crust. And a fault is always younger than the rock it cuts through. So right here you can see the fault line, and it's cut. One's moving upwards, and this one's moving down. Then let's look at the vocab. The prefix in and x help you determine the difference. So the in means inside, like inside the ground or inside the Earth's crust. And then the extrusion, it's like exiting. So you know that is above ground. And then right here it says, the diagram below shows rock layers found at the site. Circle the area in the diagram that shows an intrusion. So let's see if I can circle here. This right here. No, it's not letting me circle. Let me try again. I'll circle that. And then it says shade the oldest layer in the diagram. And I'll shade in right here. Well, I'll try to shade in right here. Just going to give you an idea. I'm not going to try to shade the whole thing because that's not working. Okay, and then it says, what can you infer about the relative ages of areas B and E? So let's see. Layer B is older than layer E. So this is E. I kind of covered up E. But B would be the older layer because the intrusion at E cuts through layer B. So that's an intrusion when it's up like that. There you go. Okay, on this page, page 207, let's take a look at a couple things. So the index fossil, right here, it's a fossil, must be widely distributed and represent an organism that existed for a geologically short period of time. So index fossils are useful because they tell the relative age of rocks layers in which they occur. So those are good things to highlight. And then if you notice in figure 4, it shows rock layers from 4 different locations and 2 of the fossils that are found in only one of these rock layers. Okay, and so let's go over to the index fossil, figure 4. Label the areas to match the first area shown. Circle the fossils or fossils that you can use as index fossils. So I've circled those here. This would be a good index fossil. This one would be as well. And it says, what can you infer about the history of location 4? Well, if you notice, B is not there, so it could have eroded over time could be your answer. And also, let's look at these. So you see the different locations, how they match up. And so I've labeled these like this is A, it matches. Over here, this matches A as well. So I've labeled these all A. Then you come across, here's B, and you can see B right here. And then B's not here, so that's why I believe it's eroded over time. And then right here, you've got C. This one is C. Now this is down here, and it's C. And then this matches up with D, and there's only one other place that it matches up right there. So you can fill that in. And then you assess your understanding. So it says an area with several different rock layers, which is the oldest? Well, we know with the law of superposition that the bottom layer is going to be the oldest layer. And then it says, how could a geologist match the rock area in one layer I can't say that right. How could a geologist match the rock layers in one area to rock layers found in another area? And they could use the index fossils right there to mark and match fossils. And so they'd know what relative time frame it was. So now that I know that you can find the relative age of rocks by superposition, intrusion, extrusions, and faults, and by the index fossils. So you can mark that down here. If you're having trouble, let me know. Okay, now turn to page 208. Things to underline would be the gaps in the geologic record, and folding can change the position in which rock layers appear. And then also here, when rock layers erode away, an older rock surface may be exposed. And then layers, the surface where new rock layers meet a much older rock surface beneath is called unconformity. And an unconformity is a gap in the geologic record, and it's lost due to erosion. So down here it shows you this is where it erodes, and here it's going to be a fold. See how it erodes, and then like there's a fold in it. So you can go through that. And then here, relate text and visual. Underline the sentence that explains how the rock layer is in figure 5. Well, right here, we've already kind of done that. It's due to the rock layers, then deposition begins. That we can underline that one too. So layer erodes away and the old is exposed. Then deposition begins, building new rock layers on top. So that's what this one right here is asking you about. And down here it says shade in the oldest and the youngest layers in the last 2 diagrams. So let's see, the oldest layer, I will get this out. Oldest layer I'll do in red. So it's this here. And this one here is red. Those are the oldest layers. You get the drift. And then I'll do the newest layers in yellow right here. So you can do that on yours. And yours probably will fill in much better than mine. Okay? Okay, now we're moving on to page 209. So something key to look for is folding. Forces inside the earth fold rock layers so much that the layers are turned over completely. So here you can see the way it's folded in the different areas. So let's apply that. What does this show, the photo show? It shows folding, and you know that because the areas are bent. And then after what can you infer about the history of this area? So after the rock layers formed, forces inside the earth raised and folded them. And this could be like an intrusion below, volcanic activity, tectonic plate movements. There's various ways that this could be caused. And then now if you're assessing your understanding, name 2 ways rock layers can change: unconformity and also folding. And then how does the folding change rock layers? Folded rock layers are no longer flat, and sometimes older layers can end up on top. And then on to C, draw conclusions. 2 locations include a layer of rock with a particular index fossil. In one location, the layer occurs in a higher position than in the other. What can you conclude about these 2 areas? Well, one area could have experienced folding. There could have been erosion. So there's different things that could happen. And then now it's like, I get it. Now I know that rock layers can change due to unconformity or folding. All right. So I hope your studying is going well. Miss you. And anyway, that's the end of the lesson. Have a good day. Thanks.